Hello and welcome. Today I wanted to give you a brief introduction to StatCrunch so that you can kind of see where things are, get in there, start using it, get comfortable with it. You're going to be using it a lot this semester. You can use it for your homework. You will definitely be using it for the project that you're going to be working on. So really important that you get comfortable with it. Once you get your account set up, then you come to StatCrunch and you see this screen here and it says Open StatCrunch. So later on, this My Data, that's where you're going to be storing your data for the project when you get the project all cleaned up. So you don't have to keep cleaning your data every time you want to use it. You'll save that data and it'll be over here in My Data. Everything else you do, you're basically always going to be using this Open StatCrunch button. So click that. And it opens a StatCrunch window for us. So this looks a lot like, you may have used Excel or some kind of similar program, but this is all geared towards doing statistics really, really well. In fact, let me make this a little bit bigger so we can see the words a little better on here. Okay, so what we have here is you can see we have rows and we have columns. So at one point, when you're working on your project, what you're going to have is each column is going to represent the responses for a particular question, and the rows are going to represent responses from a particular person. So rows are people, right? The ones going across horizontally, those are people. The ones going up and down, those are data sets for a particular question for the survey. Okay. So what I want to show you, most of the time, you're going to be living inside this graph choice or this stat choice. Usually you're going to be going to the one of those. So let's just make up some data here. Let's say that we have let's just make up ages for people in a stats class, just theoretically. So we'd have what? We've got some 18-year-olds, some 19-year-olds, maybe some 20-year-olds, maybe a 17-year-old, maybe a high school student is in there. Then we've got like 23. Maybe someone else is a little bit older. Oops. We'll change the title here to be class. Let's even be specific here. Stats, class, ages. So what we have here is a set of data representing ages for people in a stats class. And I've given it a title. This is really helpful to have things in a title. Watch what will happen if I just make up some other data here really quick. When we go in to do something like make a graph, so say I want to make a histogram. See how it says which columns do you want to choose from? Well, it's really hard if all your things are called, your data sets are all called var1, var2, var3, var4. It's very easy to pick the wrong one. But if you've given it a proper name, stats, class, ages, I'm probably not going to pick the wrong one on accident because it's got a name there. Okay, so it's really helpful to give things a proper name when give your data a proper name. Oops, let's delete these so they're gone. Okay, so let's say I wanted to know some things about this data. Well, then I could go up into stat, and we've got our summary stats. So I click columns, and we only have one data set in here, so it's only letting me choose one, but I still have to click it. And then down here, you can choose what you want it to calculate for you, but there's kind of some basics that it always calculates. And these are the ones that are in blue there. You can pick up these other ones if you want, but we don't use those as frequently. So then I'll come down here and click compute. And you can see what it's done is it's calculated a lot of the things that you're going to be learning about in this class, right? Soon, right? So it's got the name of our column, stats, class, ages. It's got N. N generally represents the size of our sample, so the sample size. So there are 14 data items in this set. So it's telling us that right here. There are 14 items. Sometimes you'll notice that that number is less than your items over here. That means that StatCrunch couldn't read it. For instance, if someone wrote out the word 18 in letters, StatCrunch wouldn't be able to read that, and so it wouldn't count that as a data point. It's telling us the mean is 20.7. Approximately. The variance is about 42. Standard deviation is about 6.49. Standard error. The median is 19. The range, the min, so that's the minimum value that occurs. The max is the maximum value. And then we have quartile 1 and quartile 3. These are all things that you'll be learning about here. So let me just show you. Notice if I put in here 18. This will be really important when you go through and clean your data. if I do the same thing and hit summary stats, columns, click this, hit compute, notice how it still only says n is 14 instead of counting this, because it doesn't know what to do with a word. StatCrunch doesn't, StatCrunch can't put that word 18 into an equation and crunch it, so it ignores it. So you always want to keep an eye on that sample size to make sure that it's matching what's going on over here. So like when you clean up your data, what you'll go through and do is when people answer incorrectly, you'll do your best to put it in a form that StatCrunch can read. In this case, it would be easy. Oh, they wrote the word 18. I'm just going to write it as a number. And now when we rerun those statistics, notice how now it says n is 15 because now it can count that last value. Okay, and then just like that, we've got our mean, standard deviation, median, all that kind of stuff. So it's important that you at least know how these things are calculated, but you will have software in order to do most of the calculating for you. Right, we'll use StatCrunch to actually do that. In real life, people don't generally sit down and calculate a standard deviation by hand anymore because we have nice software that will easily do it for us. Okay, so there's some other things that you'll be using over here. At some point, we'll be using some calculators, some t-stats, some proportion stats, but that comes later in the course. Okay, so regression, we'll be using down here, some different things. Under graph, we can see that there are lots of different charts that we could make. So we can go in, one of the most popular graphs you need to know how to use is a histogram. And there's a couple important things that you want to keep in mind for the charts that you're going to be putting into your project, right? And this is actually really easy to do, but it makes a big difference in your work. So at this point, I only have one set of data, so I'm going to click that. We come down here. You can play around with your starting your bins, so the start and the width. A lot of times you can affect how good your graph looks really easily by just changing a couple things here, trying a few things that work. We'll do that in just a second. One thing that you should always do, not so much the color scheme. You can pick whatever color scheme you want. It doesn't matter. They have some that are colorblind safe. So if you're going to be presenting and you think someone might be colorblind, you could choose that. There's lots of different shades here. I'll just keep it at basic. But for every graph that you make in this class, you should come in and you should write in an x-axis label, a y-axis label, and a title. Okay? Because the reality is, most people that look at your statistics are going to just look at the pictures, right? It's like when you hand people a book, a lot of times they just want to look at the picture. They don't really want to look at words, right? So you have to make sure that your graph is done really, really well. And that means that having everything labeled with units. So just like in science class where they say, hey, always use your units, it's the same thing in statistics. You should always be putting your units in there. So for instance, in this case, we would say age. And even when it's obvious, still put the unit. Like we pretty much always measure age in years, but still just put it in there. Age in years. That way there's no confusion. The y-axis, a histogram counts how many people are in each group, so we could just put count. Or sometimes you'll see that they'll use the word frequency. Frequency just means to count something. And then our title could be ages of students in statistics class. Okay, and then watch what happens when I compute this. It gives me a histogram, but look how, if I handed this to someone, I wouldn't have to say a word and they would know what this graph is about because they'd go, oh, well, the title tells me that it's ages of students in statistics class. Okay, so I know we're talking about ages of students in statistics class. And down here, we're looking at the age and it's in years, which they probably could have guessed years, but always a good idea to put your units there. And then this over here is the frequency. It's the count. So this tells me, oh, between 15 and the cutoff is 20. So it's really between 15 and 19. There were, it looks like nine occurrences of that in our data set. For people that are age 20 to 24, there were 5 occurrences of that. And for people between the ages of 40 and 44, there was 1 occurrence of that. So see how we can clearly see from this histogram, it conveys the information that we need. Think of this as a game. If you give someone a graph or a chart and they have to ask you what it means, then you lose. You just did a bad job, right? Your goal should be that when you hand someone a graph, all the information that they need is right there on the chart. like this one. Okay, so always go in and change those three things: the x-axis, the y-axis label, x-axis label, y-axis label, and the title. Always change those. Okay, and here we also can do some things. What if I say, I don't know if that's the right one? Look how fast this is. We can change the width. The width was what, at 5? Let's change it to 2. And now I hit compute. Notice how I get a slightly different histogram. It shows our information slightly differently, right? This one breaks it down even more. It's showing us, here we have the numbers of 15 and 16-year-olds. There's 1. Here we have the number of 17 and 18-year-olds. There's 6. And the numbers of 19 and 20-year-olds. So you can break those bins down into different sizes and get different groupings. And see how it only took me a second to come up with that other version? This is one way in which you can quickly find a graph that represents your data the best. And it'll take you less than a minute to do that, but it makes it look way more professional. If you just automatically go with the settings that StatCrunch gives you inside of here, they're probably not going to be very good because StatCrunch doesn't really understand what you're trying to show. It just goes through, crunches some numbers, throws them in a graph. But you have the power to go through and say, I can make that graph look even better. And then, we change it around. Maybe we want the width to be 1 of our bin. So we hit compute, and now we get a little bit different looking one. And maybe you go, no, I don't really like this. I'm going to go back to where it was 2. I think that was the better looking one that can, and by better looking, we mean the one that conveys the information that you want to convey about the data, right? It's not about being pretty. It's about the whole point of statistics is what is the story that's hidden in this data. So if this is the best picture that conveys the story, the information that's hidden in your data, then that's the one you should use. But see how you can easily jump around and find the one that works best for what you're trying to do. It's very easy to make all sorts of stuff. Pie charts with data. Make one of those. I'll skip the label, but again, you should always be coming down and giving it a title. And if these are options, you should be putting them in there. Hit compute. Here it gives me this. Pay attention in this chapter. You'll see pie charts are way overused. They actually are not as good at conveying information. They make a nice, pretty picture that's nice to look at, but they actually are not very good as a representation. It's harder to compare these. Like, for instance, here, if I look at 17 versus 42, which one of those pie slices is bigger, and by how much is it bigger? Right? How many of these 15 pie slices would fit over here into this one? It actually is a lot more complicated for your brain to try to break that down. What you really want to be using is something more like a bar chart. Generally, you want to be using a bar chart over a pie chart. They might not be as pretty, but they actually give you a better understanding of the data. When you're ever stuck, the first place to just ask yourself, is it a graph? And if it's a graph, look under graph. If it's not a graph, it's almost like it's very likely to be under the stat column right there. Now, sometimes you might not know the name of what you're looking for. You might go, oh, am I trying to use Z stats, or am I trying to use T stats, or do I want proportion stats? I'm not sure which one I want. The easiest thing to do is to go onto YouTube and just look it up. Look up StatCrunch, proportion, 2-sample proportion hypothesis test. And then there's going to be a real short video, probably a minute, where someone shows you exactly what to click on. They'll show you, there'll be a video where they go up to stat, come down to proportion, 2-sample with data, and they click it, and then you just follow along, and you'll do the same thing that they're doing, okay, in order to find it. So I know it can be a little intimidating at first when people don't know what these things mean, but like I say, just go into YouTube, type in what you're trying to do, and someone will have a video showing you exactly how to do it. Okay, so here I just made up some categorical data, right? We can see over here, what we have on the left, this is quantitative or numerical data. These are measurements and they're numbers. You can have numbers that aren't measurements, things like telephone numbers and Social Security numbers don't really measure anything, but most of the time our numerical data will be measurements. Like here, these are ages. You're measuring, how many times has the person gone around the sun while they've been alive. Here in the second group, we've got, let's just call this eye color. Okay, so now let's take a look at a pie chart. Okay, that's not too bad, but let's then also look at a bar plot. And you should be able to see it's a lot easier to compare the heights of these bars than it is to compare the widths of these pies over here. Like, is black bigger than green? And if so, by how much? It looks like blue is a little bigger than both, but how much is blue bigger than green? Over here, it's a lot easier because you're only measuring how the tops, the heights are different from each other, and it's a lot easier to compare. So that's generally the reason that we want to be using bar plots more than we want to be using pie charts. Pie charts are vastly overused by people. They'll go to the pie chart immediately when most of the time it's not your best choice. Okay, so that's your brief introduction to StatCrunch. If you have any questions, let me know.